Learn a lot of different formulas for different situations, but they all involve the same basic idea. This idea never changes. If I have 40 people in a room, actually, screw it, I don't want to talk about it. 40 people in a room, and 4 of them are left-handed. And I pick somebody at random. What's the probability I pick a left-handed person? So I got how many chances to pick a left-handed person? 4. So the probability of a left-handed person, you guys see what this symbol means? The probability of a left-handed person would be 4 chances to get somebody who's left-handed out of 40 total things that could happen. So the basic idea of probability never really changes. It's how many things match what I'm looking for. Let me even write that shit down so you know it's of note. The number of things matching what I'm looking for. Hello? Is it me? And then divided by total number that could happen. Jeez, that's a lot of words. That's the idea behind how to construct any probability. So fundamentally, probabilities are related to percentages, but not all percentages. Would it make sense to say that there's 110% chance of rain tomorrow? Not only because we live in San Diego, but also because what the hell would that mean? 100% chance of rain means it's definitely gonna freaking rain. What the hell would 110? It's so gonna rain that the rain is gonna be giant, or it's gonna rain in the next universe over too, or I don't know what the hell that would mean. So probabilities aren't exactly like percentages. Percentages can go above 100%, but probabilities can only go up to 100%. We should all know that. And of course, what's the lowest that probably could be? Zero. Does that mean it ain't gonna happen? Okay. As I teach you and we discover new formulas, I'm going to try to show you how it did not change this idea ever. This idea really can't change. We'll see how long you believe me on that, but we'll see. Okay. All right. So let me show you a situation. Well, let's do the classic situation first and get it out of the way. Here's the classic situation. In a bag. Let's make it different. I'm not going to make it poker chips. Let's say in a bag, I got 4 bananas. I got 3 oranges. And I've got 7, what? Strawberries. I like it. It's either boss or it's son of a... So what is the probability that I reach in and I pick a strawberry? Yeah, there's 14 total. Now watch. I'm going to put a wrong answer up here. The correct answer is 7 out of 14. All right? So let me go ahead and put that. That's the right answer. Which is what? 50%. Yeah, 1/2, which is 50% kick-ass. Bam. So here's, what would you tell the person that did this? The probability I pick a strawberry is 1 out of 7. Can you figure out how they thought about this problem? Bless you. And can you see how to tell them they were wrong? And maybe a nice way instead of, good Lord, man. Yes.
You would tell them, first of all, you would add 4 plus 3 plus 7, and then I know you see 1S, but it's not 1S out of 7, it's how many strawberries, which is 7, belong to the 14, which of the 3 numbers are added together.
Okay, maybe that would work. What are they looking at it as?
They're only taking into account the strawberries.
Yeah, exactly. But why do they, in their mind, is this okay? Because I want 1 strawberry and there's 7 of them. So I want to get 1 of the 7 strawberries, Jeff. This is what they're going to look at me and say, come on, tell me I'm wrong. But doesn't make any sense. I don't have a 1 out of 7 chance of picking a strawberry because I could pick something else. So how in the world could the answer not involve the other shit? Right? If I had 4,000 bananas and 3 million oranges and 7 strawberries, it can't still be a 1/7 chance. That's another way to kind of show them that it depends on how many total things. Get out of here. Okay, maybe. So don't do that. You can't look at it that way. It's all about how many chances do you have to get what you want out of the total number of things that could happen. 7 chances out of 14 things. Bam. All right? So then let's probably get a banana. 4 out of 14, which is like 28%, 28 point.
28.6.
Is it 5, 6? 28 point. Sure. I've memorized all the division by 7 because I'm a geek. So leave me alone. So don't get too excited about leaving out the division. Now how about this one? Let me give you one that's a little different. Let's probably get a strawberry or an orange. Yes, because the idea of probability does not change. What's the total number that matches what I'm looking for? 10. Because now I'm good with either one. I just don't want one of those damn bananas. My potassium level's too high already. Get away from me, banana. Get thee behind me. So then I get 10 chances to get what I want out of 14. And then I think that's like 60. Oh shit, I'm way off.
71.
So I'll stop trying to show up. 71.4. 4. Oh yes. All right. So or, can you just tell me something fundamental about or? Does it increase or decrease the chances when I say or? Increases. Why does that make sense? Because or says it could be this, or so it just increases the number that could be. Okay, I like it. We still don't know a formula for it. I want you to notice something. I haven't really written any formulas down yet. But look at all the stuff we're able to do, right? We haven't really done that much, but still. Let me just tell you this before we're going to learn some probability formulas. If I give you a situation where you're able to count everything, do not use a formula. You don't hear a math person say that very often, do you? Because probabilities are all about counting. So it's easier if you're able to count. So when do I use a formula? When I give you a situation where I don't tell you how many's there. You can't count, so then you have to use a formula. So we'll see what that looks like later. All right, so that's enough of this. Stuff in a bag should be relatively easy. So let's try something the next level up. So it's something called a contingency table. Oh shit. So we know what the word contingent means. That's right with you, yeah? Yes, all right. So contingency plan is like something to have in place in case the first plan fails. Backup, exactly. And when would you activate the backup plan? It is contingent on if the first plan fails, right? If the first plan don't fail, then the backup plan doesn't have to come into play. You guys kind of with me? So the word contingent means it depends on something else. And you're all like, okay, now make a table out of it, Jeff. All right. So here's what a contingency table looks like. Let's say I ask people a question, and they're either, let's see. You can do this, Jeff. Let's say they're either less than 21 years old or older than 21. You guys with me? And let's say that some say yes to this question, some say no to this question, some say maybe. And we'll leave it up to your own individual imaginations to figure out what the question might be. So let me just fill the table in with stuff. What you got, Jeff? So let me just ask you, go ahead and write those numbers down. So we haven't seen something like this before. You've seen something like this before, you just have. How many, all right, let me ask you, what does that 6 mean? 6 people who are at least 21 said no. You guys with me? That's how you read this. Can anybody tell me how many total people said yes? Good. 48. Keep going. 35 said no. 5 said maybe. I like it. This is all ad hoc. Good job. And how many total people can't legally drink yet? 39. At least in the U.S. And then how many can get sloshed illegally? 49. Now here's the funny thing. How many total people were there? Not too hard, right? How many total people were there? 88. But somebody's going to put 176 because it's going to say 88 plus 88. These people are these people, right? You guys see that? So just that's a quick check. This and this is 88. And if you did these right, they should come out to be 88 also. And thankfully they do. You guys, everybody with me on how to read that table? So on a test or a quiz, I like to give you one with these all blank. So you kind of jogs your memory. I got to fill those in. Because now I can answer all kinds of freaking probability questions, right? So let's find out if that's true. So what's probably somebody said no? Don't say it out loud. Just take a minute, write down an answer, and then I'll ask you what you got. Okay, what do you guys get? So you got how many out of who? 35 out of 88. If you need to borrow a calculator, you can do so. You might need one. Anybody got that for me? So let me tell you this. Give it to me as a decimal rounded to 4 places. Point. Sounds like too much. Who is it? What? Point. 3977. That's the part that was missing. Okay. Is that cool? And then you could make that 39.77%. Is that rounded correctly, everybody? I don't know what the 5th decimal place is. Huh? Okay, I like it. Cool, sweet. Probability answers has to come out to be 4 place decimal answers, and then you can make it a percentage if you want to. I don't care. You agree with me? I don't know if you guys remember. Standard deviation has to be at least how many places? Oh, I just gave it away. At least 3 places. But you can make it 4, and then you're covered, right? Probability's got to be 4 places. Then you can make standard deviation 4 places, and you're golden. If that doesn't make any damn sense, then maybe come see me. But I don't know how to make it easier. Okay. There's a purpose to my madness sometimes. So what's the probability that somebody is older than 21 in this sample? 49 out of 88. And then whatever the hell that is. One more time. 5, 5, 6, 8. So you can put 55.68% if you want to. Okay, cool. All right. So let's build on this. Let's use the one we already talked about, and then we're going to add 2 more things to our list of probabilities we know how to do. Let's probably get somebody who is less than 21, or they said maybe. what's wrong if I say it's 39 plus 5 out of 88? Yeah, if I add 39 to 5, aren't I adding these people twice? That seems unfair.
39 plus 2.
Yes, a really good way to do it, since I can just count all this shit. I got 39 people less than 21 plus 2 maybes I haven't counted yet, because I already counted those 3, right? I love it. Some of you guys look at me like I'm crazy. If I count all of these people, have I counted those people already? Yes. And it says, or said maybe. So how many maybes have I not counted yet? 2. So 39 plus 2. You guys with me? Now here's a more general way to do it. That's a simplified way because I gave you everything. You could just see it. Here's a more general way. If I do 39 or less than 21 plus 5 said maybe, I got to subtract how many? If I do 39 plus 5, who did I count twice? Those 3, so I better subtract 3. Now, right there you can just go, that's just stupid, Jeff. Why the shit would I do that? I would just do what you said. Well, probably because it's going to relate to the formula we're going to create in situations where you can't do it the quick way. There's always a method to the madness, or most of the time. So I still get 44 minus 3, or what was the other way? 39, there it is. 39 plus 2, right? So 41 out of 88, what's that? 0.4619? 5. Okay. Or 46.59%. So that just came out naturally, that need to subtract or to not count in the first place certain people because you already counted it, right? I didn't need a formula for that. But what would the formula look like for what we just did? Let's tease it out. So now we're going to create our first official probability formula. And we didn't even need it to do what we just did, correct? But that's because it was an easy question. Let's build it for the harder questions that come later. So if I have probability of A or B, for probabilities we like to use capital letters to be the variables, the situations. The probability of event A or event B happening. What's 39 out of 88? That was what? The probability of what? 39 out of 88 was the probability that they were less than 21. So it would equal the probability of A, that's right there. That's the probability of that. Yes. Plus, what's this one? In that case, it was the probability they said maybe. Right? So that's plus the probability of B minus what the shit was this? Good. So how do I say that? Who are those 3 people? I like that. That's a good band name. We are the double counted ones. Who are those 3 people? They are both less than 21. You can do it. Say the word. They are less than 21. And, oh shit, look at me get excited about it. And. Less than 21. And they said maybe. So this will be minus the probability that they are A and B. Oh, fudge. There's our first little equation. Yeah, it's the longest one, but you talk to a math person, so that is little, trust me. Here's a visual of this, another visual of this. Have you guys seen these kind of things? They may know what this is called. Venn diagram. I love it. And it could be used in a lot of different situations. Maybe you've survived this long and never seen this shit before, but I'm almost certain everybody's seen something like this. Venn diagram. No, Jeff. There you go, buddy. So if I want to know the probability of A or B, I can take everybody here plus everybody here, but what piece did I count twice? This piece I counted twice. So what is that piece? Those are all the people that are A and B, so I would subtract them off. So you can see the equation coming right from the picture too. So it either matches what the shit we did, or it matches what the shit it looks like. I mean, it's nice. Both ways agree. Thank the gods. So then I still have a job. If it didn't, forget math, well, I'll go live in caves. Okay. So that is our first little official formula. We're going to add it to our formula sheet, blah, blah, blah. Okay, let me ask you a few more questions about this. And just to remind you guys, sometimes you don't believe me. Some of you guys say you hate formulas and then you can't live without them on a test. You're like, give me the formula so I can plug shit in. We did this problem without this. Right? So if I give you a table like this, if I were you, I wouldn't use the formulas at all, because sometimes they'll make it harder than it really is. Don't worry, I will show you some situations where you have to use the formula. There's no other way. Okay, maybe. Okay. Some of you guys look like you want to hurt me, but I'm used to it. And see, you didn't even laugh at that, so maybe you really do want to hurt me. So, here's the fourth question I want to ask you. Oh, sorry.
I have a question, because when it says less or maybe, and you add up the less than 21, you're including the 29 that says that they're not.
Exactly. Of course I am. Because, all right, here we go. You ready? This is a good moment for this, because we got or up here and we got and up here, right? Let me not go fully into this yet. The probability that they're less than 21. So what kind of people do I want to include right there? Everybody who is less than 21. Do I give a shit so far what they said? No. So I'm going to include everybody who's less than 21. That's 39 people. Right? If I said, go find me people that are over 7 foot tall, and somebody brings back, and you're like, but he's wearing white shoes. And I'm like, where's shoes coming from? All I care is that they're over 7 foot tall right now, right? You're not going to exclude some from some other reason. You're going to take everybody who's over 7 foot tall. Are you with me? So I want everybody who's less than 21. Okay, there we go. We got all those people for you. Or they could have said maybe. So that's why there was a shortcut besides the formula. I could have just done 39 plus 2 extra that said maybe. But of course it agrees with the formula too. I like it. Does that make sense? A good question, but at this point I just want everybody that's less than 21. And then I add in more people because it's an or. So let me do an and problem, and then I want to talk about bouncers at a bar to explain and an or. Okay. So what is the probability that I pick somebody who's older than 21 and they said no? So think about the fundamental idea of probability. Everything that matches what I'm looking for divided by the total. So what's going to be on the bottom? 88. Because it still could be anybody. So I know the bottom is 88.
Is the top 49 minus 6?
No. I could try that.
If it's an and, you pretty much always want to add.
No. You could do this. You ready? You ready? All right, let me tell you this. You guys ever applied for a scholarship? Okay. Back in my day, it's before the internet really caught on. Oh, yeah. That's a while back. We had to go, if I wanted to apply for a scholarship, I had to go to the financial aid office. They had this book that seriously was about this big, and they would get an updated one every few weeks, and I'm like, well, that's a lot of trees out. So sorry, future generations, but too bad. So you'd open this book, and it'd say, okay, you want this scholarship? You must do the following. Be a math major. Check. Have a GPA greater than whatever. Barely. planning major in, or blah, 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 blah. And blank, and bam, and you must be a woman. Well, put that shit first, bam. And that's actually based on a true situation. Why wouldn't you put that first? So I don't read through the whole. But, so every time it said and, it was fewer and fewer and fewer people that matched it, right? So here's the and bouncer at a bar. So go to a bar, and I'm like, let me in. And the bouncer says, all right, to get in, you gotta know Jimmy the bartender. I'm like, I know Jimmy. Hey, Jimmy. He's like, oh. And you gotta dress nice. I'm already gone, right? And you gotta have a lot of money. I'm like, double gone. So I have to match all of those. So even though I do know Jimmy, I had to also do these other things. He ain't gonna let me in. So and is the mean bouncer. You have to meet this requirement and this requirement. So and is always gonna make the number become smaller. What about if it was an or bouncer? Jeff is going to the frickin' or bar. They probably water down their booze, but you just drink more. Sorry. So go to the or bar, and the bouncer says, whoa, to get in this bar, you gotta dress nice. Or you gotta have a lot of money. Or you gotta know Jimmy, the other Jimmy. I'm like, I know all the freaking Jimmy. So then I can go in. Because it's this, no. Or, this, no. Or, this, I'm in. So or always increases the number that match. Because then it doesn't matter which one. You just have to have at least one of them, right? Yes?
It's kind of like when you're applying to a job and it says you need your social security and, but it has a list, and then it says or, but it's and on top and then or.
Yes. Exactly. And I'm about to go get my driver's license updated and get the real ID, and it says you must come with this, and or, and then it's like, or, these are the things that'll work. This or this or the, yes, exactly. So in real life, we hit the ands and the ors every damn word. Okay, maybe. So let's come back to this. So be on the top, it has to be this and this. How many people are this and they said no?
6.
Yes. In fact, do you see why we sometimes call and an intersection? What's the intersection of this and this? Freaking 6. Maybe? So this is 6 out of 88. And then, whatever the hell that is. Nobody's going to help me out? Oh, what is it?
0.0681.
Who's it say one?
82.
82? 6.82%. All right, I love it. Cool. Sweet. Everybody get that? Yes, cool. So basically, we don't know the formula for this yet. We're not quite to the point where we can get a formula. So far, we only know how to do an and if I'm able to count shit. We don't know enough yet to actually make the formula for it, believe it or not. Okay. So what about this question? What's the probability that they said yes given that they are less than 21? Let's see if you guys can tease that out. That's a new thing now. So what is it? What information am I giving you? Everybody gets this kind of wrong the first time. That's right. So what's the probability they said yes? I don't have a freaking clue what they said. What's the probability they said yes? Given that they're less than 21. So I know that they're less than 21. So what does that change? The bottom. Bottom ain't 88 anymore. How many people could it be?
39.
Yeah. And again, what is it that I know about the person? Given that they're under 21. So how many people am I talking about? 39. You guys see that? What's the only time the bottom will change? If you see something like given, if I give you information. right? So then this will be over 39.
Is it 48?
Say again? Sorry. Now, real quick. Mathematically, why would 48 not make sense up here? Because the answer would be bigger than. It'd be bigger than 1. Right? And also, 48 people out of 39 doesn't make sense. But I'm not coming down on you. It is the probability they said yes, right? But given that they're less than 21, so which people am I throwing out? Those people. So I'm living in that first row, right? So out of 39 people, how many said yes? Done. And then whatever shit that is. Does that make sense? If I'm giving you that they're this, I can't include everybody who said yes because I'm throwing out the other people, right? So what would this formula be? Oh, actually, what is this? Just to kind of finish this guy off.
1794.
1794. Sounds like a history quiz now. 1794. All right. Yeah, we're doing quite a lot today, right? I mean, I'm throwing a lot at you. To be honest, we're doing several sections out of 3 right now. But hopefully you see why. It's all from this one question I can ask all these different things. So they're all very well related. Okay, I'm going to take this away here so I have some more room. We got to figure out what the shit we just did. What the formula would be for this. What the formula would be for this in general, right?
You should put that on the shirt.
What the flapjack? Yeah, I like that. What the formula? What the function? That's even better. What the function? All right. Did I tell you I have a shirt, but I can't wear it to school, but it's... Yeah. I came up with the idea, then I searched the internet and I saw somebody made a shirt. I'm like, oh, I gotta give you props, so I bought the shirt. Yay, where am I gonna wear this? I don't know. So I wore it to a friend of mine in Seattle, and the guy in Seattle airport actually started laughing. I'm like, oh, you know what it means? Oh, sweet. Enough of that shit. So, not the 6. So let me pull this back up here. Probably a yes. And let me show you right now, that's the symbol for given. Yes, given less than 21.
It's just like a big line.
Yep.